Welcome back to Math with Miss Reimer. Today we're looking at how to multiply and divide scientific notation. There's three basic steps to how we'll solve these problems. The first is that we're going to multiply or divide the front numbers, depending on what the problem asks for. Second, we're going to use our product rule or our quotient rule to change the exponents. Remember, product rule says if you have two exponents on the same base, you can add the exponents. If you have two bases that are the same, you can subtract their exponents for quotient rule. The last step is we have to make sure that our scientific notation is in proper form. That is, for instance, even in this problem, see that the first number is in between 1 and 10. It's not greater than 10, and it's anything 1 or larger. So if it is not, if it's too big or if it's too little, we can use the acronym LARS to help us get it into proper form. LARS means if I need to move my decimal to the left, I add that many to the exponent. If I need to move my decimal to the right, I subtract that many from the exponent. So in problem 1, the first thing we need to do is multiply or divide the front numbers. So we're going to take our 2.8 and our 1.9, and we're going to multiply those together to get 5.3. And then the 10 to the 7th and the 10 to the 4th, I can add those exponents, leaving me with 10 to the 11th as my final answer. Because the 10s are the same, I can add the exponents. Think of commutative property. It says that you can move things around when you're multiplying, and they mean the same thing. Like 4 times 5 is the same as 5 times 4. That's how we get these two multiplied together, and these two multiplied together as well, still in a multiplication statement. In number 2, I'm again going to take my front numbers and multiply those together. So 1.3 and 4.7 will multiply together to give me 6.11. And then my powers, my 10 to the 9th and 10 to the negative 5th, 9 plus negative 5 will give me 10 to the 4th. In number 3, we're going to again work with our front numbers. So we've got 3.4 and 8.5. And those multiply together to give us 28.9. My powers will give me 10 to the, we have negative second, and we're going to add 6 to it. So right now you'll notice that 28.9 is too big. We need to move our decimal to the left once in order to get a number in between 1 and 10. So because I moved to the left once, I'm going to add 1 to my exponents. So I will have 2.89 times 10. Originally it should have been 10 to the 4th, and then you add 1, and so it ends up being 10 to the 5th. In number 4, again, you're working with your front numbers first, so multiply the 2.5 and the 7.5 together, and then that will give you a front number of 18.75. And then when we look at our exponents here, we have an 11 and 10, so that gives me 10 to the 21st. Now, this number is not in proper form yet, so I need to move the decimal once to the left, which will give me 1.875. That number is now in between 1 and 10. And then because I moved my decimal once to the left, that means I have to add 1 to my exponent as well, which will leave me with 10 to the 22nd. Remember that exponents are powers of 10, so when I move the decimal place one time, I'm changing a power of 10, which is why I can just add to the exponent here. In number 5, we're going to look at our front numbers first as well. So we'll take our 3.7 and our 5.6, and we'll multiply those together. And when we do, we will get 20.72. And when we look at our powers, we have a negative 2 and a negative 3, and when I add those together, I get negative 5. This isn't in proper form yet. I need to move my decimal 1 to the left, which means I also have to add 1 to my decimal, or to my exponent rather. So we get 2.072 times 10 to the negative 4th, because of the negative 5 plus 1. In number 6, we're going to deal with our front numbers first again. So we take our 1.64 times our 3.5, and that will leave me with 5.74 as my front number here. And then when I look at my powers, I have a negative 24 and a 27. So when I add those two together, I will get 10 to the third. This number is in proper exponent form because this number is in between 1 and 10, so that's my final answer, and I'm finished. In number 7, I have whole numbers for my front numbers, but I still do the same thing. So you'll do 3 times 5 first, and 3 times 5 will give me 15. And then with your powers, you'll take 10 to the 4th and 10 to the 6th. 4 plus 6 will give me 10 to the 10th. This is not in proper form yet because 15 is too big. So we're going to add in my decimal point at the end of the number and move it back to the left one place. So I add 1 to my exponent, which leaves me with 1.5 times 10 to the 11th. We do the same thing when we divide. So in number 8, we'll divide the front numbers first, and that will give us our new front number, and then we'll work with our powers as well. So 3.72 divided by 1.2 gives us 3.1. And then when we look at our powers, we use our quotient rule, which says that I can do 8 minus 5 because my powers are being divided. So that will give me 10 to the third. This is in proper form because 3.1 is in between 1 and 10, so I'm good to roll. In number 9, I need to look at my front numbers first. So we'll take the 6.4 divided by 4.0, which will give me 1.6. And then for the negative 4 and the 6, when you've got negative exponents and you're subtracting, you just want to keep an eye out because they can be a little tricky. So negative 4 minus 6, sometimes when we write it, then we can see, oh, they're both negatives. So that means that my final answer will be negative 10 because I have negative 4 minus 6. Both are negatives, so you'll add and keep the sign to give me 1.6 times 10 to the negative 10. This is in between 1 and 10, so we're in proper form. In number 10, we will divide 2.7 and 2.4, which will end up giving us 1.125. And then when we look at our powers, we have a negative 5 and a negative 6. So negative 5 minus 6 is going to give me 10 to the negative 11th for my division. And this should make sense to us because when we divide these two powers, our number should be getting smaller, and 10 to the 11th, negative 11th, is much smaller than both of these numbers together. And then our last two examples, in 11 and 12, we first need to look at our front numbers. So we get our 2.1 and our 2.8, and that will equal 0.75. And then when we look at our powers, we have 7 minus 3, so that will give me 10 to the 4th. Right now, these numbers are not in the proper form yet because 0.75 is too little. So I need to move my decimal to the right one place, which means I subtract 1 from my exponent. My acronym is LARS, left add, right subtract. So because I moved it 1 to the right, I subtract 1. And so that means my final answer will be 7.5 times 10 to the third as my answer. And then lastly, in number 12, we're going to look at our front numbers first. So we'll do 20 divided by 3.2, which will give me 0.625. And then when we look at our powers, I have a 6, and then I'm going to need to subtract negative 7. So that's a bam bam, or a double negative. So actually it's 6 plus 7. So I get times 10 to the 13th. I'm not finished yet because this number is too little, so I need to move my decimal 1 to the right, which means I have to subtract 1 from my exponent. And so when I do that, I'm left with 6.25 times 10 to the 12th. That's all today for Math with Miss Reimer. Remember the 5 things. You are lovable, valuable, changeable, forgivable, and never alone. I hope you're confident in the math. I hope you feel like you know what you're doing, but more than anything else, I hope you know that I care.